In this video, let us look at what minors and cofactors are. So let us first deal with an example. So if you take a matrix A, so let us say that it is a 3 by 3 matrix. Let us take an example 1, 2, 1, 3, 1, 4, 1, 5, 3. So let this be a 3 by 3 matrix. So we know that there are 9 elements in this matrix. 7, 8 and 9. So this is the element A11. This is the element A12, A13, A21, A22, A23, A31, A32, A33. Now, the minor of an element in the matrix A. There is the minor of the element in the matrix A corresponding to the 1, 1 position. It is minor of this one. A11 is 1. The minor of this element is nothing but the determinant of the submatrix after eliminating the first row and the first column. So if you eliminate the first row and the first column from A, what is the submatrix that you get? 1, 4, 5, 3. The determinant of this submatrix is the minor of this element. That is 3 minus 20. We have already seen how to find the determinant of a 2 by 2 matrix. 1 into 3 minus 5 into 4. 1 into 3 minus 5 into 4 is minus 17. So the minor corresponding to the 1, 1 position of this matrix is minus 17. What is M12? M12 is the minor of this element. So the minor of 1, 2 element is the determinant of the matrix after eliminating the first row and the second column. First number corresponds to the row, second number corresponds to the column. If you remove first row and the second column from the matrix, the submatrix that you get is 3, 4, 1, 3. So what is the determinant of this matrix? 9 minus 4 is equal to 5. So similarly, if you want the minor of any element, minor of 3, 2 element. So what is the minor of 5? Remove the third row and the second column. Remove the corresponding row of this element and the corresponding column of this element. So what is the matrix remaining? 1, 1, 3 and 4. The determinant of this matrix is nothing but M32. 4 minus 3, which is equal to 1. So in this way, you can find the minor of each and every element of this matrix A. So if I have to define the minor of a matrix. So if A is a n by n matrix, the minor corresponding to the ith row and jth column element is nothing but the determinant of submatrix of A after eliminating the ith row and the jth column is called MIJ. So if you want M21, if you want the minor of this element, you just need to remove the row corresponding to this element and the column corresponding to this element, and whatever is the 2 by 2 submatrix that you have, the determinant is called the minor of this element. Now, after defining the minor of a position, we define something called a cofactor of the position represented by Cij. whose definition is minus 1 whole power I plus j times mij. The minor corresponding to ijth element, if you multiply it with minus 1 whole power I plus j, you get a number which is called the cofactor of that particular position. Minor is just the determinant of the submatrix after eliminating the corresponding row in the corresponding column. And if you multiply mij with minus 1 whole power I plus j, you get something called the cofactor corresponding to that position. So I hope you understand what minor and cofactors are. So now let us go forward, take an example and look at these minors and cofactors. So let us take an example again. So if A is the matrix 1, 1, 3, 2, 1, 4, 1, 2, 1. So what is the minor corresponding to 1, 1 element? M11 is, you just need to eliminate the row corresponding to 1 and the column corresponding to 1. You get a submatrix here. The determinant of this is M11. 1 minus 8 is minus 7. Similarly, once you understand this concept, I'll write all the different minors. So what is M12? The minor of this element. So if you remove the corresponding row and the corresponding column, you get 2, 4, 1, 1. So 2 into 1, 2 minus 4 is minus 2. M13, this element. If you remove the corresponding row and the corresponding column, you get 4 minus 1, which is equal to 3. Next, M21 of this element. 1 minus 6 is minus 5. What is M22? Correspond to this element, you remove the row and the column, you get 1 minus 3 is minus 2. What is M23? M23, you remove this and this, 2 minus 1 is 1. M31 is 4 minus 3 is 1. M32, 4 minus 6 is minus 2. M33 is, you remove this row and this column, 1 minus 2 is minus 1. So you get all the minors correspond to different positions. Now, the minors matrix is the matrix M, whose positional elements are these numbers. That is minus 7, minus 2, 3, minus 5, minus 2, 1, 1, minus 2, minus 1. So this matrix is the minors matrix. Now, we have something called the cofactors also. So what is C11? By definition, C11 is minus 1 whole power 1 plus 1 times M11. So C11 will be very closely related to M11 with an extra minus 1 whole power 1 plus 1. So as you can see, minus 1 whole square is plus 1. So C11 is same as M11. So you have minus 7. So what is C12? Minus 1 whole power 1 plus 2 times M12. So now 1 plus 2 is an odd number. So minus 1 whole power odd number is an odd number. So minus of M12. Minus of minus 2 is plus 2. So what you need to observe is, if I plus j is even, Cij is exactly same as Mij. If I plus j is odd, Cij is equal to the negative of Mij. So now as you can see, so correspond to 1, 1, 1, 3, 2, 2, 3, 1 and 3, 3. I plus j is even. So 1, 1, 1 plus 1 is 2, 1 plus 3 is 4, 2 plus 2 is 4, 3 plus 1 is 4, 3 plus 3 is 6. So corresponding to these 5 elements, the value of I plus j is even. If the value of I plus j is even, Cij is exactly same as Mij. So in the matrix, can you locate these 5 positions? 1 1 position, 1 3 position, 2 2 position, 3 1 position, 3 3 position. So these 5 positions do not change their signs. So C11 is exactly same as M11, C13 is exactly same as M13, C22 is M22, C31 is M31, C33 is M33. And corresponding to these 4 positions, I plus j is odd. Corresponding to these 4 positions, I plus j is odd. So if I plus j is odd, these 4 elements get an extra -1 with them and they change their signs. Whatever sign they have, they change their signs. So usually how to remember this is, if you take a 3 by 3 matrix, you get something like this: a cross mark and a rhombus. So cross mark means you don't need to change anything about those elements, and the remaining 4 elements have to be changed their sign. So what is the cofactors matrix for this? The cofactors matrix, usually denoted by C, is nothing but these elements on the into sign are exactly same. You don't need to change anything. That's what into means. No need to change anything. So -7, -2, -1, 3, 1 remains same, and the remaining 4 elements have to reverse their sign. So this -2 becomes +2, -5 becomes +5, -2 becomes +2, 1 becomes -1. So this is the cofactors matrix. This is the minors matrix. Now, if you want to find cofactors and minors of a higher order matrix, obviously you need to know how to find determinant of a 3 by 3 matrix, right? Because if you have a 4 by 4 matrix, 1 2 3 4, 1 2 3 4, so what is the cofactor of this element? Cofactor or minor of this element is the determinant of the matrix obtained after removing the corresponding row and the corresponding column. So you get a 3 by 3 matrix now. So you have to know how to find the determinant of a 3 by 3 matrix. For a 3 by 3 matrix, you have to know how to find the determinant of a 2 by 2 matrix. So we know how to find determinant of a 2 by 2 matrix. So we have found the cofactors and minors of a 3 by 3 matrix. Now, to find the cofactors and minors of a higher order matrix, we'll try to define how to find determinant of a higher order matrix.